So this is what came up when I Googled lateral area of a cylinder. So a cylinder is like a can of soup, right? So I'm talking about finding out the area of that Campbell's soup label, right? So if I cut with my scissors right here and I cut up like that and I unroll the label, it'll look like this. And we talked about when we were doing shells that this length would be 2 pi r, and this length, 2 pi the radius, that's the radius, and this length would be the height. So the area, as far as lateral area goes, is 2 pi r h. Well, the thing about it is that if I want to find the surface area of rotation of something, some curve, okay, so let's call this curve f of x equals y. Let's rotate it around the x-axis, okay, and we'll stop it right here, start it right here, and stop it right there. If we want to imagine that surface, it would be like this bell shape, right? This kind of deal. But it's three-dimensional, you know? And I'm not talking about finding the area on this side, that circle side. I'm not talking about finding that area. I'm talking about finding just, we're going to call the surface area of revolution, just that part there, just the side. So I'll shade that like in yellow, just the sides, lateral sides, okay? So that's going to be coming from just this part right here and not coming from the end, not that circle part on the end, okay? That's what we're going to call the surface area of revolution. Well, if we imagine following those same set of steps that we do all the time, where we draw the area, imagine it, okay, and slice it. We want to decide delta x or delta y, delta something, and calculate the quantity, which is surface area for one slice. So that's our goal right now. So let's see. If we want to make a slice, it would make sense to make the slice kind of somewhere randomly in here. It would have the x-axis on one side of the slice and it would have this curve on the other, right? And what I'm after is finding that area of revolution that is made by just this portion right here. So you could sort of attribute that to a cylinder, right? But it's not quite a cylinder, you know? It's got this curvy side to it, but otherwise it's like cylindrical in shape. And I'm only interested in finding this area as it comes around, all the way around, right? I'm looking for that area. Well, it looks almost like a cylinder, so why don't I just say that the area, I'll call it delta area, area of one slice, lateral area of one slice, is 2 pi the radius times delta x, right? Because this would be my change in x is my little slice there, right? So that would be the height of my cylinder. And my radius, I'll call that the radius of revolution. But the problem lies actually right here. Delta x is not straight across. It's straight across here, but it's not straight across there, right? There's some curve to it. And we have to account for that. How do we account for how long that is? How do we find how long that is from here to here? That's an arc length. And we find arc length by doing integral ds, right? Delta s when we're talking about a little slice. So really, I don't want delta x here. What I want is delta s. And that's going to be my lateral area of one slice. It is 2 pi radius of revolution, whatever that's going to be. In this case, that radius of revolution is actually the curve times delta s. So you're going to end up with, when you want all the lateral area of revolution, surface area of revolution. When you want it all, it's going to be a limit of Riemann sum. Take all those slices and add them together from A to B, right? You'll have a 2 pi on the outside, kind of like shells. You'll have a radius of revolution, and then you're multiplying that delta S turns to ds. Now remember my options for ds. It could be 1 plus dy over dx, the quantity squared, dx, or it could be ds is 1 plus dx over dy, the quantity squared, dy, depending on whether I want to be in terms of x or in terms of y. And what this calculation is going to give me is the surface area of revolution from A to B on the function. But we need to see some examples on how we find this radius of revolution and how that kind of changes depending on which selection we make of ds.